All right. Thanks a lot for the nice introduction. This is work that I did together with Frederik Wiehr and Sven Gehring from the German Research Center for Artificial Intelligence. I quickly would like to take you out of the virtual world and let's go back and look at something that is quite physical and less virtual. So 20 years ago, SIGCHI and Ulmer came up with these terms of tangible bits and tangible user interfaces and really started lots of these things that, or gave them a new framework, so to speak. And they did it because they thought that it would be good to encapsulate the digital information and make use of our manual capabilities and all these capabilities that we humans, that we live in a real physical world already have. And also to make use of our spatial memory. And if I would start my talk with, as we all know, tangible user interfaces help generate spatial memory, none of you would step up and scream no, that's not true, or whatever. It's a very accepted fact. But the problem is that lots of the proof that we have about it is quite anecdotal. And so we were interested in whether this is actually true. So do spatial tangible user interfaces help in the generation of spatial memory? And if you look into the related work, I mean, there's lots of it, but those ones that deal with actual physical tangibles and looking into how they help you organize your spatial information or organizing information spatially, there's only little work actually that looked at or used also the term spatial memory. And for example, one of the first ones was Patent and Issue, where they looked at how to organize or how would people organize newspaper articles if they had just a simple token for them, and then they realized very soon, okay, spatial memories, tangible user interfaces are very good to create spatial order and so forth, and you would do it to a larger extent because they are easier to manipulate. This you already saw in the last presentation, so I don't have to say much about it. Kim and Maha actually looked at how to use tangible user interfaces to help designers understand arrangements of icons. As you can see, back in the days, there was no direct connection between the screen and the tangibles and so forth, so were basically trackable tokens. And they found that it helped designers to understand the buildings and arrangements in a better way. So that is one of the first cues. But once again, you have to also think about it. They just tested whether they understood the relationship between objects better, not whether they actually could memorize these objects better, or these relationships. Calls et al. Once again, you've seen this before in the last talk. So they looked into comparison or teaching people, first of all, how an anesthesia machine works, and they compared different sets, and what they had was an AR overview and versus a desktop versus an actual physical machine, and they found that the AR actually worked best when no physical machine was around. So basically it helped them to memorize the locations of the different buttons they had to press. And then pretty much the last one already in this long area, this long field from 2012 is the comparison between virtual and tangible objects to memorize or to understand and train spatial skills. And once again, they found that tangible user interfaces helps to understand the spatial properties of 3D elements, which is probably not as surprising as one would assume. And so we were okay, they all seem to prove in some way that it helps to understand the relationship between the objects better and so forth. But spatial memory also means that you can actually recall these informations later on again, that it's actually something that can also be to some extent transferred to a different setting. And then we started looking into spatial cognition literature, and we designed a user study, and that is going to be a bit more complex, I guess. So the user study is split into two tasks. The first task which is the placement task, where the participants had to organize buildings on a map using either a GUI or a TUI. And then the Recoil task, which is basically a task where the users in a slightly changed setting had to show that they can still memorize what was going on. And in between, we introduced a break, just sort of similar as beforehand. So the placement task, we developed this user interface, which was basically the same for both of the different conditions, where on the right side you would have a bunch of buildings, either printed physically, so as a tangible, or as a graphical user interface that would be just an icon. And then you had to arrange those buildings around a map. This map contained 16 markers on which the participants had to arrange 8 buildings. Those were basically try and error, so basically they had to move them towards when the GUI was a drag, was in the tangible, they could just pick them up and place them. And if they were placed wrongly, the marker would light up red. If they were placed correctly, the marker would light up green. I hope you can see this down there. And just rearrange until they are finished. Same for both tasks. In the second task, they had to recall these positions. And what we did here was we changed the settings. So beforehand, we used a tabletop. This is now just a simple desktop computer, so the screen was a little bit smaller, and it was slightly off from the original, and all the original information was hidden from them, and so forth. And then they had to rearrange them on the map, and they had to do this from memory, and there were no markers anymore on the map. So they would just see a building popping up on the right, and then they had to place them on this map on the desktop computer using a mouse. And then we had the in-between task. And the in-between task, it lists 2 very prominent usability questionnaires, but it's actually completely bogus. We also introduced, instructed the conductor of the study to talk to the people, and there were cookies and there were drinks and so forth, just to create a gap of roughly 10 minutes. And not roughly, but exactly between 9 minutes and 30 seconds and 10 minutes before switching to the other task, so that the user actually had to, or the participant had to think about something else and create some distraction between those 2 tasks. And this is heavily inspired by studies in spatial cognition, where users see one setting and then have to recreate it in a slightly different setting, and in between they have to think about or do something else. And so these questionnaires pretty much don't give us much information that would be actually in any way useful. As you might have seen already, we used a Microsoft Sur 40, so this formerly called Surface tabletop, which had a 40-inch display, if I recall it correctly. We used SimCity 2000 buildings, which you can conveniently find on Thingiverse, because we decided to have buildings that don't really resemble anything that you would know, so we decided against, for example, using the Eiffel Tower or whatever. Then we used the Microsoft Fiducial marker kits, so we 3D printed them with an Ultimaker 2, put a marker beneath it, and then we had 2 sets of 8 buildings, and we also had 2 different maps, so that you would never see the same map again, San Diego and New York. Before the study, for both of these maps, there would be created, the markers would be created, but the positions of the markers were always the same for each of the maps, but the maps and the buildings were counterbalanced between participants. We had 20 volunteers, 8 of which were female. They were aged between 21 and 38 years, with an average of 29 years. And And 12 of those 20 had in some form used a tabletop interface before. And none of them, or I think only 2 of them had, and it's not on the slide, but I think it was 2 that actually had used tangible user interfaces beforehand. They would get a short introduction to the way the interaction works. We had an additional set of buildings, so that I think the SimCities 2000 set contains like 20 buildings, and we had another set of buildings with 4 additional ones and another map. The map, by the way, didn't contain any form of markers, so there was nothing written on it, no street names, nothing. And then we counterbalance between the building set, the map, and the interaction condition. And each participant would first conduct the first placement task with 1 set of building, 1 set of map, and then a short break, then the recall part, then another short break, then another placement task with the difference. So we had an within subject design with a different set of building, different set of map, and the other interaction method. Again, a short break, and another recall task. Yes. We measured the trial completion time, even though from the beginning we didn't expect much meaningful out of it. The number of repositions during the recall task, which basically just happened by accident, but it's quite interesting to look at in the end. And then our main measure was the accuracy in the distance, in the recall task, meaning how good were people at recalling the positions and how well did the spatial memory work. And this was just the Euclidean distance in pixel between the original position and the placement. We were asked by the reviewers to add centimeters, but centimeters is actually we added it to the paper, of course, but it's probably not the best measurement because we had the switch of setting, and while the resolution for both screens were the same and the measurement of the map were the same in pixels, they of course differed then in centimeters because the screen size changed. Then in the end we did a self-assessment and asked the people whether or in which interaction they thought they performed better and why. And of course, as I said, these NASA, TLX, and ISO questionnaires can be ignored. But of course, there were results. Interestingly, we didn't find any significant difference in task completion time, but that is probably maybe because this was just a trial and error task and it didn't really have much to do, and we didn't ask them also not to do it as fast as possible. So that is probably the explanation for it. However, we found a statistical significance in the recall accuracy, and here the tangible user interface performed significantly better. We used a repeated measure ANOVA, and as you can see, the average distance of the target for the GUI was 266 pixel. For the TUI, it was only 201 pixel. And there was no difference in the set of the maps, as you can see in the graph below. So set 1 and set 2, those are the different maps and buildings. And yes, and then you see the combined, that the tangible user interface is significantly better in the recall task. Interestingly, we found that there is we found a significant difference in the number of changes in position in the recall task. So our participants would normally move or switch the buildings again, so they could arrange them and then think about it and then could rearrange them as they liked, as often as they liked. And they did it like up to 3 times more often in the TUI task, so after the TUI task. And that is also statistically significant difference, and I will hopefully, or I have some idea why it is like this, because that was also part of the self-assessment, because 15 out of 20 thought that they performed better with the graphical user interface and not the tangible. And when asked why they thought about that was the case, they explained that it was hard for them to, because for the graphical user interface, the image that was used on the surface and the image that was used in the Recoil task was the same. While for the tangible user interface, we had a picture or a photo taken off with roughly the same angle, as you can see, of the actual 3D printed object. We originally thought it was easier for them to recognize it, but in the end, apparently they had some problems matching the objects, the buildings to the right other building. Yes, so quick conclusion. This paper provides further evidence that you actually can create transferable spatial memory with tangible user interfaces. As I said, on average, participants performed roughly 24.5% better. And what I would like to say here is in a map interaction task, I would not put my finger up for anything else, and I also would not claim that it's necessarily scalable. So right now they had to remember the position of 8 buildings. I'm not sure, and I assume it's not the case from connected spatial cognition literature that you actually can do much more than 10. So there's some possibility for further research and further evidence how it actually works. Because especially now that we see that those tangibles actually starting to emerge, especially in the learning sector, it would be nice to understand why they work and how they exactly work to actually make them better for everybody. Thanks.
Thank you, Markus. Questions?
What value do you think the tangible aspect, the touch aspect, has relative to spatial movement?
Yeah, that was actually my first thought was, oh yeah, of course, you make use of the tangible and then you make use of your kinesthetic cues and so forth. And then I was like, wait, if I do pretty much the same movement except that I'm just moving and the kinesthetic cues should not help. So for me, I guess the best thing or the idea behind it is that probably that because you pick it up and position it, and then you focus less on and that is my inner, that's all speculative, as I'm saying, but my explanation myself is that because you are moving it around, you're focusing on the interaction while you are doing it and less on the actual position that you are placing it, while if you're picking it up, you put it down and you don't have to look, right? You don't have to do anything because it's so easy for us to put things on certain positions that you're focusing more on the position. That is probably, if you could, maybe if we would have implemented the GUI different in the sense of you click once on the right side and then you click on the left side, it might actually have a different turnout. So yeah, that's where I'm seeing there is a lot of potential to, if we really want to understand why they work so well, to extend on it.
It's really interesting. Did you notice that users sort of slid objects, or did they pick up and drop?
So for the tangibles, it was directly immediate that they did something like this. Something more radical, that they would really just put them down where they wanted to have them down. While for I guess all of us have used a Surface or the Sur 40, and we all know it's not the most pleasant touchscreen to ever have used. So yeah, maybe also this can have an influence. I would not root out that even the stickiness of the surface can have an influence on that, and that if you would use a Surface tablet, for example, it might be different. I think there are lots of variables that you can play with that I assume would have some form of influence there.
Thank you.
Time for a short question.
There's one.
So have you looked into the errors they have made while placing the objects, and then the correlation of that, the number of errors versus the total time taken probably to finish the task, the placement task, and then recall task.
So it is really hard to, do you mean the number of errors in the first task?
Yeah.
And then the recall? We didn't look into it, but I assume because the number of errors was actually there was only a very small standard deviation. There was always around around 10 to 12 trials that they needed, because of course with every building that you place, the number gets lower. So I assume, but no, we didn't look into it. Maybe that's something else to look into.
So first task was the placement,
Yeah.
and second was recall. So what about the total time taken between the two kinds of recall tasks?
What do you mean? There was like a 10-minute break after you finished doing this. There was like a 10-minute break between the placement and the recall task. And then there was another 10-minute break between the first recall task and the second placement task. And then again, a 10-minute break between the second placement task and the second recall task.
Okay.
Let's thank Markus again. Thank you, Markus.